Hello, hello, hello. We are finally back with a new episode of ConveyorU. I'm sorry for my voice, I have a little bit of a cold. But anyway, I will try to bring this home. Okay, so today, finally, I go back to applications. I would like to talk about buffering. It's not like we are done with the product description. As you can see behind my back, there are some more kind of packaging that we need to talk about, but I would like to take a break for that kind of video in order to be able to discuss a little bit more about applications again, because we're really getting bored actually. So buffering, buffering and why buffering is extremely different from accumulation. Just a little bit of a reminder, somewhere over here will pop up a link to the video where we remember what is accumulation and what is not accumulation, in order to lay the grounds for a review if you need it before going on with this video here. Okay, so as we recall, accumulation is when the products are touching each other and they are pushing one against the other. Okay, buffering for us it's something different. Buffering means creating a device that has the possibility to store an extra capacity of products in such a way that if the line downstream, machine downstream stops, we can go on and produce without being forced to stop the upstream production. Now this is possible also with accumulation normally, but of course if we go fill the empty and blank spaces on the connecting conveyor, the space available, the number of product that we can continue to produce is going to be very low. While with buffer, the device is working like kind of a vessel. So you have like, imagine your production like a water flowing to a tube. If the valve downstream gets stopped for whatever reason, you need to make this water flow somewhere else, and the buffer is going to be the vessel to contain this kind this extra production in order for you not to stop. Okay, so the typical situation is that the buffer is used to manage idle stop, micro stops, not major breakdowns in the line, because in that case we are talking about stoppages of maybe even hours, and there is no kind of device that can handle that kind of storage space, not let's say a dynamic one, at least. So when we talk about buffering, we talk about managing the idle stops, and that typically requires a buffering capacity of about 5 minutes. Most of the idle stops, micro stops, can be cleared in less than 5 minutes. So this is the typical situation. And another thing to make a buffer worthwhile is that the buffer must be capable, when the downstream machine restart, to give back products together with the normal production flow in order to achieve 100% capacity, so to recover the production that was lost during that micro stop. To do this, the downstream machine must be correctly sized, so the downstream machine must be capable of an overdrive speed. So typically this overdrive speed is about 20% of the normal production. So you have 100% of the production coming from above, from the upstream line, and the buffer is able to keep up to 500% of this capacity for 5 minutes of production, and the downstream machine is capable of handling 120% of a production rate. So this means that the buffer will get empty in about 25 minutes. Okay, this is the typical situation, and is the one that we really push to achieve 100% efficiency of the line when using a buffer to handle idle stops. Another point, and this is not really common for everyone, but in our opinion, the buffer should be zero pressure. Okay, so the products should be as close as they can in order to maximize the capacity of the available space inside the buffer, inside this vessel where you take the product out of the line and keep them until the production can go back online. But they must not get in touch between each other, because if you have long buffering queues, the pressure against the products is going to be extremely high, and the products are going to be damaged. So in our opinion, of course, the buffer must not have accumulation. The products must be very close one to the other, but never touching. Okay. Of course, there are some kind of product that allow this kind of handling, so buffering through accumulation. But for most of our application in the food industry, it's not so good. Let's say that the exception is cans, maybe vacuum packed product, but not much more than that. Okay, we will not get into the details of each kind of buffering device in this video. We will do that in future ones, but before closing it, before wrapping it up, I want to remember the main kind of buffering that we have. We have three kinds of buffering. The most typical one, and is the one that we use a lot, and we have made tens of machines during the years, is the LIFO buffer, so last in, first out. This means that the buffer is reverting the motion and giving back the product in such a way that the last product that got inside the buffer is the first one that's going back to the line. This is a configuration that is a viable option only when the product has a long shelf life and can be kept in storage even for a long time, so maybe 30 minutes or more than that, because it may happen even if the buffer has a theoretical empty time of 25 minutes. If another idle stop occurs before you manage to empty completely the buffer, of course you will have the first product that got inside the buffer that is going to be waiting much more than 25 minutes before getting out. So this is the limitation of this kind of buffering solution, but also we have to consider that last in, first out is the best, has the best cost to space ratio. Sorry for the interruption. It's a windy day here, and I needed to clear a locked window because of the wind. But anyway, so where were we? Okay, so last in, first out, best cost to storage space ratio in the lot. Okay, then we have first in, first out. This is, of course, the opposite one. So first in, first out means that the first product that gets inside the buffer is the first one also to get out. This is the option that one would select for short, either fresh products, short shelf life products, or even frozen one like frozen pizza, frozen meat, frozen vegetables, ice creams, all this kind of stuff that of course cannot stay out of the cooling cycle, the freezing cycle for too much time. And this kind of solution is used when the product has the capability to stay outside the cool area for a maximum of 10 to 20 minutes. The lesser the better, okay? This kind of machine, of course, it's less cost effective. If we have the same kind of buffering space, typically we will see that the price per meter of buffering space is going to be double than the last in first out kind of buffer. Then there is another upgrade of this one, and this is the first in first out buffer with traceability of the product. So in this case, not only the product that gets inside the buffer are the first one to get in, are the first one to get out, but also the buffer is a machine capable of keeping the exact same sequence of arrival at the exit. So product number 1 is going to be product number 1, product under number 100 is going to be product number 100, not only inside the buffer but in the whole process. Okay, so in this way you are going to keep track of the production exactly in the same way that the processing machine has put it out. This is extremely important for sterile products or any kind of application in which you need to have a complete knowledge of the production process, and you need to be able to isolate the production lot one from the other. Okay, and this third kind of buffer is of course the most expensive one, and also mechanically speaking the most complex kind of machine, and this really should be used only when really is necessary to keep the traceability of the product. This being said, remember this. This is the really, let's wrap it up with this consideration. Okay, there are a number of situations, especially with the first in first out buffer, in which a standby machine is going to be less expensive than the buffer. Okay, and so sometimes one project engineer could be tempted not to put the buffer inside the line, and just to put a standby machine. This consideration depends so much about what kind of production do you have, what kind of machine do you have, that is impossible to make a general rule of what is better to do. But for the moment, just to close this, let's say that of course there is the possibility to take out the buffer and put a standby machine, but remember that the buffering has always an advantage in terms of the capability to balance what is happening from the process side, in the primary packaging side, on the secondary packaging side. So a buffer is going always to be useful to make the line run more smoothly. Okay, so balancing all the kind of differences of production between one machine and the others. So this is important to take into consideration, even when the buffer may be more expensive than a standby machine. Okay, so for the moment this is it. This is the basics of buffering theory. We will get more into how buffer works, looking inside each kind of the three major categories of buffering that I just described. So for the moment, thanks a lot. See you soon on ConveyorU.